Go Seahawks! Woo! Go Hawks! Such a good game. I texted Lucian immediately after it. He's my Seahawks go-to. This game had one Sir Lucian, and it was Lucian going for the Hawks. So regardless, lesson 2.1, let's figure out the rest of this little intro to graphing idea. And graphing linear equations or line-making equations. So for the notes today, we're going to have a few more things to write down and a few less problems to do. And what I want you to write down firstly is this definition. A linear equation is an equation whose graph is a line. And the more we see this, the more obvious I want you to know this idea. It makes a line. And the second bit I want you to write about is the solutions. So solutions are the points on a line that are solutions to an equation. The points on the line for that equation are the solutions. Really, all these line-making equations is a bunch of solutions so packed tightly together that they look like a line. And last little thing I want you to remember is that an ordered pair xy is used to locate a point on a coordinate plane. Most importantly, that x comes before y. You guys see that's alphabetical. Pretty cut and dry. Okay, now that you've written those 3 points down, let's look at what they actually mean on our graph here. Let's interpret this. If I say when x is -1, y is 0. And if we plot that line, or that point, we get -1, 0. And these are solution points for the line x, so y plus x equals 1. When x is 0, then y equals 1. They plug in 0 for x, and then y equals 1. When x is 2, y equals 3. See how these are going up so nicely? It's so ordered and even. It looks like you can start to see a pattern for this whole line. This is what we're going to learn how to do. What we are learning first is the easiest way to graph. This is the way that's most consistent and will always work for you. And that way is making a table. So if they say graph the y equals -2x plus 1, all we got to do is make a table for when x equals a value, then we find out what y is. So we just plug in things that are easy and are close to home. So like when x equals -1, plug -1 in for x. See how that goes? -1 in for x, y equals 3. So our solution point is the value that we plugged in and the answer that we got. Again, we do it for when x is 0. We plug in 0 for x, and we get our answer and plot that solution point. When x is 0, y is -1. And lastly, when x is 2, plug in 2, y equals -3. 2 times -2 is -4, plus 1, -3. So if you're doing this right, if you choose at least 3 values, that'll ensure that you don't accidentally have one solution point over here or down here. You'll see that they all line up in this beautiful straight line that they've done. I'll scribble all over. See, I get to write in my book. Please don't write in yours. The fourth thing I would like you guys to write down is this key idea that graphing a horizontal line. So this says the graph of y equals a is a horizontal line passing through 0, a. Remember when we had our equation y equals bx plus a? And this was b could be any number that was multiplying x, and a is any number that's added or subtracted to x. Well, this is what this a means. Y is whatever that number is that's being added or subtracted to x. So, but when they say y equals x, and that's your whole entire equation, all you have is a bunch of solutions that give you an answer. So when x is I don't care, y equals a constant number or just one number. And if that's the case, it doesn't matter what x equals. You see, x could equal anything down here. Y is still going to equal whatever number is for a, and it'll be a straight line for eternity. Write this down. The reason we have notes is so we can reference them later and say, hey, we learned something. So real quick, to make that last equation make sense, they say graph y equals -3. And if I were to be silly, and let's say I'll make a little table, say when x, we have x and when y. When x is 4, well, y is going to be, if we reference over here, y is going to be -3, no matter what. So that means y is -3. How about when x is 0? Y is still -3 because it don't occur. What about if what about if x is pi? Y is going to be -3. If x is decline, you know what? Y don't occur. It's going to be -3. So that, if we were to plot all those values, like if we were to plot 4, 0, we plot David Klein over here, it's all going to be -3, -3, -3. Gives us a nice horizontal line. Alright, here are a few on your owns I want you to give a try. And the pattern for all of these is going to be, number 1, make a table. Make table. You can write these steps down in your paper. 2, plot solutions. Make a table with at least 3 values so you can plot solutions. 3 of them. It goes for both of these. And lastly, check to see if straight, because if you can't draw a straight line, then you may have messed up somewhere in your table. So it's like, you know 2 of your values are right, but which 2? That's why you need a third one. It's like having 3 witnesses or 3 branches of government. So for number 1, we'd make a table when x equals, I do like when x equals -1, 0, +1. That'd be super easy. Make a small graph. So for when, on number 2, I'd choose numbers like when x, I do numbers for x that are reciprocal of -1/2 would be -2. So I'd use at least -2. 0 would be an easy one. And 2. We starting to notice a pattern here? And please, for number 3 and number 4, if you understand what it means when you just have y equals a number, how would you graph that line? Hint, hint, it's probably going to be something like this. That's horizontal. I'm having a top ramen noodle break because it's super late. Tastes like college. And I'm back. They give us a little equation. Here they're talking about, hey, the wind speed in miles per hour, this is wind speed y, miles per hour, of a tropical storm is, and they give you this equation that figures out what the wind speed would be. However, your other variable and what would make the difference in wind speed would be x, or the number of hours that after the storm enters the Gulf of Mexico. So they figured out that when a tropical storm enters the Gulf of Mexico, it starts to become bigger and more ferocious and you can track it with this equation. So what they do first is to graph the equation so we can start plotting our data. And we think to ourselves, what a crazy world that when you have a tropical storm, it grows like this. So they started out, of course, after no time has passed. What is the wind speed? And if you plug in 0 for x, the wind speed equals 66 miles an hour. Ooh. After 1 hour, you plug it in, and it looks like you add 2 miles an hour to that. Ooh. And then you add another 2 miles. And then you add another 2 miles an hour. And they went ahead and they graphed all of these points over here. And we get this nifty little straight line of a graph that goes up, 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 up. Check 1. So you can cross off A off your list. And 2, they say, if you see here on the left of the screen, that a tropical storm becomes a hurricane when the wind speeds are at least 74 miles an hour. Aye, aye, Captain, it's going to be a hurricane. And they want to know, when exactly does this storm become a hurricane, or when does the wind speed get more than 75 miles an hour? Well, if we see here, this is 74 miles an hour. This is 74, and they went over till they hit the line, just like we do in science. And they hit the line right here. Now they go and ask ourselves, how many hours have passed? And then it reaches that. And it looks like, ooh, when 4 hours passes, we get a 74 mile an hour storm. But do not despair. What happens if we get another type of hurricane to come in? So they say, what if? What if in example 3, the wind speed is instead calculated by this equation? Instead, y equals 1.5x plus 62. When does this storm become a hurricane? So they want to know, when does this storm pass 74 miles per hour? If you reference your instrucciones that we had up at the top, you'll see that you need to make a table, and you need to see if you actually need to plot the solutions. You can solve this from a table, and then if your answers are right, you'll see this. It goes up an even amount each time, just like in this table, went up by 2 miles an hour, up by 2 miles an hour, and so on. This one, what would you guess it would go up by? So go ahead and tell me, after how many hours does this storm become a hurricane? I will see you in class. Have fun? Can I say that?